All right, hi everyone. This is Unit 1, Lesson 2, Solving Linear Equations for Algebra 1. So we're going to go ahead and get started. All right, so solve linear equations. In this lesson, our lesson essential question is how do you create equations and use them to solve problems? By the end of this lesson, you'll be able to create and solve linear equations with one variable. All right, example 1, solving linear equations. What is the value of x in the equation 2 times the quantity x plus 4 divided by 3 minus 8 equals 32? So there are a couple different methods that we can use to actually solve this. Completely up to you which method you want to use. Both methods will work. Okay. So method 1, I'm going to multiply both sides by 3 first so I can get rid of that fraction. So if you don't like fractions, I recommend doing it via method 1 because it just gets rid of it for you. Now, of course, you need to know that, like, I'm looking at my denominator, so I only have a denominator of 3 for this. So I just multiply everything by 3, it gets rid of it. So I multiply 3 times the 2 times the quantity x plus 4 divided by 3. That gets rid of that 3, so I have just the 2 times x plus 4. Okay? 3 times 8 is 24, and then 3 times 32 is 96. Then I'm going to multiply this 2 through. 2 times x gives me 2x, and then 2 times 4 gives me 8 minus 24. I'm going to combine my like terms on the left side, so that 8 minus 24 gives me a negative 16, and then I'm going to add that 16 to both sides. So 96 plus 16 gives me 112. 2 divided by 112 gives me 56. You can also add 8 to each side first. So if I do that, 32 plus 8 is 40. Then I multiply by 3 to get rid of that fraction. 40 times 3 is 120. Then I divide by 2, which gives me 60, and then I subtract 4, which gives me 56. So again, there's a couple different ways to solve these. As long as you're following the steps correctly, you can do either method, or another method will probably work as well. So something that I would have done is I would have multiplied by 3 first. Then I would have added the 24. Then I would have divided by 2 and then subtracted 8. That's the way I would have done it. But again, you don't have to do it that way. There are other ways to do it. So again, you can distribute, you can divide what's on the outside of the parentheses. There's a whole bunch of different ways to do it. Each solving method yields the same solution. Is one method better than the other? No. Look at how the expression on the left side of the original equation is built up from x. So x, I added 4, then I multiplied that times 2, then I divided that by 3, and then I subtracted 8 from that whole thing. Notice how method 2 applies these steps in reverse to isolate x. This is often a good strategy and can lead to simpler solution methods. Okay. Again, completely up to you. All right, let's try it. I want to solve the equation 4 plus 3x minus 1 divided by 2 equals 9. Explain the reasons why you chose your solution method. So I'm going to basically undo what I would have done to x. So for me, I'm going to subtract 4 first. So the first thing I'm going to do is I'm going to have 3x minus 1 divided by 2 equals 9 minus 4. So that's the first thing I'm going to do, because that 4 is all alone. It's outside. It's not affected at all by the fraction. So I'm going to subtract that first. That gives me 3x minus 1 gives me 5. Okay. The next thing I'm going to do is multiply both sides by 5. Okay. So again, I divided. So now I'm going to undo that division with multiplication. So I'm going to multiply this side by 2. So that gives me 3x minus 1 equals 10. Okay. The next thing I want to do is I want to subtract that. I have that minus 1, so I want to do the opposite. So that's adding. So I'm going to add 1 to both sides. So plus 1. So I get 3x equals 11. And then I'm going to divide both sides by 3. So x equals 11 over 3. You can always double check your answer for these. So you can substitute 11/3 back into the equation, the original equation, to see if it works. If it does work, then you did your job correctly. If it doesn't work, you might have made a mistake somewhere along the lines and you might want to double check and fix it. Okay. So if I have 11/3, I'm going to substitute 11/3 in for this x up here. So 11/3 times 3 gives me 11. 11 minus 1 is 10. 10 divided by 2 is 5. 5 plus 4 is 9. Okay. Example 2, solve consecutive integer problems. So the sum of 3 consecutive integers is 132. What are the 3 integers? Okay, so I'm going to pick 3 numbers. They have to be in order. So like 1, 2, 3, 4, 5, 6, 21, 22, 23. Like, see how they're in consecutive order? That means they come one right after each other. So write an equation to model the problem. So I start with x. That's my first integer that I'm using. And then my second integer is x plus 1. And my third integer is x plus 2 because they're 3 consecutive integers. So they go 1, 2, 3, like they go right after each other. Okay. And that sum, when I add all those numbers together, that equals 132. So I have x plus 1 plus x plus 2 equals 132. So on this side, all I'm doing is adding things. So I'm looking for my like terms. I have 1, 2, 3 x's. So 3x and then 1 plus 2 is 3. So 3x plus 3 equals 132. I'm going to subtract 3 from both sides, which gives me 129. And then I'm going to divide both sides by 3 to get x by itself. So x equals 43. So that's my first number. Again, I have 3 consecutive integers. So 43. 43 plus 1 is 44. And 43 plus 2 is 45. Okay. Make sure, especially on problems like these, that you're reading through the instructions and giving an answer of what they actually asked for. So they might just ask, what's the first integer? And all you have to give them is 43. Most likely when you're doing consecutive integers like this or something along these lines, whether it's like 2, 3 consecutive even numbers add up to be this number, like things like that, they'll give you what they want. So in this case, they wanted all 3 integers. Make sure you give them all 3 integers. All right, let's try it. The sum of 3 consecutive odd integers is 57. What are the 3 integers? So I start with x. That's my first integer. It's an odd integer. Okay. If I add 1 to that odd integer, it makes it an even integer. So instead, I'm going to add 2. So I get x plus 2. So again, odd integers, so it would be 1, 3, 5. So I'd add 3 the first time, and then I'd add 4 the second time. So plus x plus 4. Okay. So this is my first odd integer. This is my second odd integer. And this is my third odd integer. Okay. And this is going to equal, it said sum, so equals 57. Okay. Now I can simplify the left-hand side. So I have x plus 2 plus x plus 4. There's 3 x's. 2 plus 4 is 6. Again, still equals 57. I'm going to subtract 6 from both sides. So I get 3x equals 57 minus 6, which gives me 51. Then I'm going to divide both sides by 3. So x equals 51 divided by 3, which equals 17. So my first integer is 17. Now, my second integer, again, it's odd. So it's not just consecutive, it's odd consecutive, okay? So 17, my next odd integer would be 19, and then 21, okay? So because 17 plus 2 gives me 19, and 17 plus 4 gives me 21. All right, example 3. A lab technician needs 25 liters of a solution that is 15% acid for a certain experiment, but she has only a solution that is 10% acid and a solution that is 30% acid. How many liters of the 10% and the 30% solutions should she mix to get what she needs? So again, I'm going to write an equation. So write an equation relating the numbers of liters of acid in each solution, represent the total number of liters of one solution with a variable like x. You can choose any variable that you would like. Okay. Then the total number of liters of the other solution must be 25 minus x. So 25 liters of 15% solution, remember of means multiply in mathematics, equals the amount of liters of 10% of the solution plus 25 minus X liters of 30% solution. So again, I have two solutions available to me. I have a 10% and a 30%, and I want to make this 15%, but I'm still making 25 liters. Okay. So I have 25 times 15%. 15% becomes 0.5, 0.15. 25 times 0.15 is 3.75. Then I have 0.110x representing that 10% solution, and 7.5 minus 0.3x representing that other 25 liters of the 30% solution. Okay. So I have 3.75 equals 0.1x plus 7.5 minus 0.3x. I'm going to combine my like terms, and I want to subtract some things and move some things to the other side. I want all my variables on one side, all my numbers on the other side. So in this case, we subtracted 7.5. 3.75 minus 7.5 is negative 3.75. 0.1x minus 0.3x is 0.2x. I'm going to divide by negative 0.2. 3.75 divided by 0.2. Again, that negative goes away. Gives me 18.75 equals x. Okay. So that means since x represents the number of liters of the 10% acid solution, the lab technician should use 18.75 liters of the 10% solution, and then 25 minus that 18.75 to represent the 30. So 25 minus 18.75 is 6.25 liters of the 30% solution. All right, let's try it. If the lab technician needs 30 liters of a 25% solution, how many liters of the 10% and the 30% solution should she mix to get what she needs? So again, she's going to start with that 30 times that 25%. So that's 0.25. That's going to equal X, because that's the number of liters I need for that 10% solution. So times 0.1 or 0.110 plus 30 minus X, because it's 30 liters, times 30% solution, so 0.3 or 0.3 or 0.30. Okay. So now I'm going to do some multiplication. Again, you can pull out your handy dandy calculator for this. 30 times 0.25 is 7.5 equals 0.1x. 3 times 30 is plus 9 minus 0.3x. Okay. Then I want to combine my like terms. So 7.5 minus 9 equals 0.1x minus 0.3x. So 7.5 minus 9 is negative 1.5 equals negative 0.2x. Then I want to divide both sides by negative 0.2. That gives me 7.5 equals x. So I need 7.5 liters of the 10% solution and 30 minus 7.5 2.5 liters of the 30% solution. All right, example 4. Use linear equations to solve problems. 4 friends use an online code to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of one ticket without the discount? Okay. So the first thing that we want to do is write an equation to represent the problem. Let P represent the original ticket price. So 4 times the original ticket price minus 15 equals 312. Okay, and actually tells us the discount over here. So 4 tickets, they have a discount of 15. So the price is what we're missing. Okay. So I get 4 times P minus 15 equals 312. Then I want to solve the equation. Divide by 4 gives me P minus 15 equals 78. add 15 to both sides, gives me 93. So the ticket price without the discount was $93. All right, let's try it. The same 4 friends buy tickets for 2 shows on consecutive nights. They use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Write and solve an equation to find the original price of the tickets. Okay. So I have 8 tickets. And we'll say T minus 5 because the T is the original price of your ticket minus the $5. And that equals $416. I'm going to divide both sides by 8. So that's T minus 5 equals 416 divided by 8 is 52. Then I'm going to add T minus 5 plus 5 equals 52 plus 5. So that's T equals 57. Each ticket was $57. All right, example 5, solve work and time problems. LaTanya will walk her bike from her house to the bike shop. So here's her house, bike shop, okay, which is 1.5 miles from her house to get the bike fixed. She expects to wait 30 minutes for the repair, then she will ride her bike home. Can she be home in an hour? So right now it takes her she can walk 3 miles per hour, okay? So her time walking is 1.5 miles divided by 3. She's walking 3 miles per hour, plus the half hour that she's waiting at the bike shop, plus her 1.5 mile trip back home at 10 miles per hour, divided by 10 equals her total time. So the equation 1.5 over 3 plus 1/2 plus 1.5 over 10 equals T. So in this case, they multiplied by 30, which is the common denominator. So 30 times 1.5 divided by 3 is 15. 30 times 1/2 is 15. And 30 times 1.5 divided by 10 is 4.5. So 15 plus 4.5 equals 30T. So I add this together. 15 plus 15 plus 4.5 is 34.5 equals 30T. I divide both sides by 30. I get T equals 1.15. It will take LaTanya 1.15 hours or 1 hour and 9 minutes to get home after leaving to get her bike repaired. So she'll need more than an hour to get home. All right, let's try it. LaTanya leaves her house at 12:30 and bikes at 12 miles per hour to Marta's house. She stays at Marta's house for 90 minutes. Both girls walk back to LaTanya's house along the same route at 2.5 miles per hour. They arrive at LaTanya's house at 3:30. How far is Marta's house from LaTanya's house? Okay, so start at 12:30. I get home at 3:30. So 12:30 plus 12:30, 1:30, 2:30, 3:30. That's 3 hours. So we know that this is equal to 3. Okay, that's the total amount of time that they spent. So we know that she biked to Marta's house. So that's 12. So that's X, well, X over 12. Plus, she stayed there for 90 minutes. So that's 1.5 hours. Bring everything in hours, okay? And then they both walked back at 2.5 miles per hour. Okay, so here's my equation, the way it's set up. So 3 equals X over 12 plus 1.5 plus X over 2.5. So I'm going to multiply this through by my common denominator, 2.5 times 12. My common denominator is 30. 3 times 30. Multiply by the common denominator, which is 30. 3 times 30 is 90, equals 2.5x plus 30 is 45 plus divided by 2.5 is 12x. So 90, I'm going to minus 45 equals 2.5 plus 12. That gives me 45 equals 14.5x. Then I'm going to divide both sides by 14.5. So 45 divided by 14.5 gives me 3.1 approximately. Okay. So Marta's house is about 3.1 miles from Latanya's house. Concept summary. Create and solve linear equations. Use the following information about Kelsey's visit to the flower shop. Kelsey bought some roses and tulips. That's nice. She bought twice as many tulips as roses. Roses cost $5 each. Tulips cost $2 each. Kelsey spent $36 total. How many kinds of each flower did Kelsey buy? So I can write an equation to represent the situation. So the cost of roses, the cost of one rose, times the total amount of roses she bought, plus the cost of one tulip, times the total number of tulips she bought, equals the total cost. So $5 for a rose, so 5 times x, plus 2 times 2x, tulips cost $2 each, and she bought twice as many tulips as roses, equals 36. Multiply through. 5 times x is 5x, 2 times 2x is 4x, equals 36. 5x plus 4x is 9x. Divided by 9 gives me 4. So Kelsey bought 4 roses and 8 tulips. And that is the end of Unit 1, Lesson 2.